All right. So, fun fact, semi true story. But once my wife and I got engaged, she went to Europe and left the planning for the finances, getting things set up to me. And I discovered that my wife just never actually paid off her credit card bill. Thankfully, it wasn't thousands of dollars, but it wasn't a little bit either. We're just gonna say it was $250. Um, and I did talk about this previously, but no, in all of our previous questions, we would have borrowed some money if it was a credit card question. Some time would be passed, and then we'd pay it all back at once. But lending companies aren't okay with that. They want you to make a regular payment, even if it's a small one. So in this one, we're going to just track what happens. Janelle owes $250, but all she pays back is the minimum payment of $10 per month. We're just going to track this for 6 months. We're going to do one question by hand using the table, and then we'll start using our solvers for it. Janelle's interest rate on her credit card is 24% interest, but it's compounded monthly. This is a realistic rate for a credit card. So here we go. You guys don't need me, but essentially we add on that 2% interest every month to get our ending balance at the year, and then Janelle pays off $10 of that balance. Just a bit of calculator work to get going. I might pause the recording because people watching on YouTube don't need to see that, but you guys can tap back in once you finish the table. Okay. So hopefully you guys have something similar. Something to notice. This is like the bad side of compound interest. Janelle made $60 in payments, but her balance did not go down by $60. That would mean she would owe $190. Her balance is still $218.46. So if Janelle paid $60 to the company, how much of that card balance has she actually paid off? That's an easy thing to do. And you can eyeball it. It's about $30, but she owed $250, and now she owes $218.46. Can I do the mental math this morning? Yes. That's $31.54 was paid off. So that kind of sucks. Paid $60 to the credit card company, but only $31.54 of her actual debt was paid off. And then it's not too hard to calculate the interest there. She paid $60, and of that, $31.54 went to paying off her debt. The remainder, can we hit that mental math there again? $28.46 is interest. So it's wild. Just in 6 months, this credit card company, just because Janelle is choosing to make the minimum payments, has made an easy $28.46 off Janelle. So it's no wonder that our banks and credit card companies pull in billions a year, because lots of people do this. The dangers of compound interest. So far, it's been good planning for retirement. But yes, the downside. Now, this is the last time we'll do a table. Let me show you guys how we could have done this on the TVM solver. Everything basically works the same. Note that N here is not years, but it's not deposits or withdrawals, because this is a scenario where we make regular payments over time. But yeah, this question, it's 6 payments. It's just 6 months from the table. And the interest rate for the whole year, 24. For borrowing questions, our PV is positive, so positive 250. Janelle's making a minimum payment of $10. So hopefully you've been trying to get your signs right. If she's making a payment, that would be minus 10 because the money's leaving Janelle. If you put in PMT as positive 10, that just means she keeps borrowing $10 every month. And we're solving for what is left after those 6 months. And then it's a monthly question, so 12 and 12. Everything still matches so far. But yeah, can you guys slam those in? We should get the same balance of 218.46. We should. And then our mission today is just to expose you guys to a few different types of scenarios with borrowing. The tech is still the same. Should be good. Let me do it as well. So I did link a new one in the news feed on Friday that was able to do interest questions. The other one was producing some errors. Yeah, we should be good. 24 is 250. This will work. Of course it will. 218.46. I didn't doubt it. Not for a second. It's negative because that would be what Janelle would have to like pay back. So it's okay that it's negative. Minus 218.46. I don't think we need to make another concluding statement here. But yeah. So switching gears, we've now seen that while we're paying back some money that we borrowed, unfortunately, that debt continues to accumulate interest, and a lot of what we pay off goes to that interest. How much depends on what we borrowed, how much we borrowed, and the rate. Let's look at some more examples. Here we go. Different type of problem. Let's say Janelle wanted to have it paid off in 6 months. How much would she actually pay? Obviously, $10 wasn't enough. So let's make a tweak. Everything else is the same. 6, 24, 250. This time, can you guys set your FV to 0? The loan is all gone. It's all paid back. Set FV to 0 and resolve for PMT. I shall play catch up here. We are setting FV to 0. So we're expecting something much bigger than 10. And I got minus 44.63. Minus is okay because we're losing that money as we pay it back each month. 44.63. 44.63 per month. So as you guys are seeing, absolutely no new tech skills today. We're just using TVM solvers to do a new type of problem. Just for interest's sake, how much did she actually pay back? What is 6 payments of 44.63? I just have my calculator out here. 6 times 44.63. So Janelle ended up paying back 267. I have the space. I can write this down. That's 267.78 in total. So that's like $17.78 in interest for the pleasure of putting $250 on her credit card. The dangers of credit cards. Okay. Most of you guys are going to have a credit card. Be looking at situations like that. Most of you, not everybody, but most of you guys will be having to borrow money for a car. In this case, we're going to look at how to kind of reason out the purchase price of a vehicle. A lot of vehicle ads just tell you how much you're going to be paying per week or every 2 weeks. So this advertisement I pulled from several years ago, but the idea is still the same. This is advertised as $99 per week, which seems pretty good. It's a low number. I'd rather see $99 per week. It looks more appealing than here's a truck that's $40,000 or $50,000. But we're going to see. Let's just look at the math behind that. So inside the small print there, it says that you're actually paying this for 7 years, and the interest rate is 5.3%, and it's compounded weekly because we're making weekly payments. So let's actually work out how much we're borrowing here, and then just do a few little calculations together. All right, so N is our payments, right? For 7 years, we're making weekly payments. So how many payments is that? That is, I think it's 364. I'm going to double check that though. 364 weekly payments. The interest rate, 5.34. We're paying $99 per week. And with our borrowing questions, like our living off money questions, okay. Like our living off money questions, a lot of the time our FE will be 0. Here after 7 years, the truck is all paid back. And this is a weekly question. We're making weekly payments, and interest is calculated weekly. So let's look at here how much we're borrowing, and then maybe it'd be worthwhile to look at how much interest we're paying for the pleasure of paying for this truck over 7 years. There's my mouse. All right, 364. 5.34. Solving for PV. PMT, minus 99, because we're making that payment, we're losing that money. 0 and 52. And 52. All right, I got just over 30,000. Let's just jot that down, and then let's have a conversation about a couple things. Maybe make a calculation looking at how much interest we're paying over those 7 years. So 30,054.44. I can remember that number in my head, surely. 30,054.44. Well, not French. All right, so we have found the equivalent cash price. It is about 30,054.44. All right, a few things. One, we talked about in our last lesson, actually, smaller businesses, when they're selling their product, would rather get the guaranteed money up front than have to wait a bit for their money. So instead of getting 7 years of payments out of $99, it might be better for the company and cheaper for you just to get all that money up front. So this dollar value here is worth a lot less than 364 times 99. And if you're running a small business too, remember, you can take less money up front, and then you can invest that money, and you can be making interest off that money. So anyway, that's why our equivalent cash price is a lot less. Another reason too, some of you guys have already purchased cars, and you understand that not only are you paying for the car, but there's some GST, there's licensing fees, there's other fees that go into purchasing a vehicle, which is why our cash price is less than the price in the illustrated in that diagram there. Let's do one more thing. Let's find out how much interest you'd be paying for this car. Can you guys find out how much 364 payments, just a little something extra here, of $99 is? Just humor me. How much is that? I got $36,036. That's how much you're actually paying for the car. How much is the interest? Well, we can just take the difference between what we were paying, 36,036, minus our, how's the short-term memory? 30,054.44. Nailed it. I mean, you guys can eyeball it. It's about 6,000 in interest, right? Exactly, it's 5,981.56 in interest. If you haven't purchased a car before, a lot of dealerships have their own kind of financial branch, because why wouldn't you? If you could also turn your car dealership into a kind of bank, and every time somebody bought a car, not only are you getting the profit from the car, but you're getting $6,000 in free money of interest. Why not do that? And if you're thinking, why would anyone sign up for this? Well, now we're getting to the reality of most people don't have tens of thousands of dollars to buy a car with cash. Most of us are going to be in the situation where we have to make car payments. And this is just the reality for most of us. All right, so we've covered credit cards. We've covered car payments and equivalent cash price. Anything you guys want to chat about so far? All right, So far, everything P/Y and C/Y have always matched. We're going to have there's one scenario where they don't. And this is the scenario of mortgages. So we're going to talk about, this was 15 years ago. And then for your final performance task, I've kind of updated things so it's a bit more realistic for you guys. But yeah, we looked at credit cards, we looked at cars. For most of you guys, the biggest purchase you might make would be a mortgage for either like a condo, a home, a trailer, like lots of stuff you could get a mortgage for. A mortgage is just a fancy word of saying borrowing money for someplace you live. When I took out my mortgage about 15 years ago, everything, what I had to borrow or what I had to pay for the house was $301,000. Now, they would not just let me borrow that full amount. I had to put something significant down to show I was committed and that I could actually financially pay for the house. So back then, they just wanted your money. You didn't have to put down as huge of a down payment as you do these days. I had to put $11,000 down as a down payment. What is a down payment? Essentially, just cash you pay up front. You can't pay the full balance for the car, the home, whatever. We pay a little cash up front to kind of reduce how much we're borrowing, but it's also a bit of a security for who's lending us money. So I'm going to add kind of both of those things here. That's probably good font. I'll say this, an initial amount of cash you pay up front to, I'll do this. 1, reduce how much you have to borrow. So it's a benefit to you. You know, if you can afford to not borrow as much, then you pay less in interest. But 2, provide security for the lender so that you just don't borrow the money and then like take off. All right, we're going to just do what we do. We're going to analyze this scenario with the TVM solver. So before we begin, let me address the only scenario for you guys where your PPY and your CPY won't match. You guys recall the first assignment I gave to you guys when you compared compounding frequencies? You guys remember that one? Remember that the more often you calculate interest, the higher the future value is, which is good if you're saving money. But if you're borrowing money, that's bad. And if you're lending, like if you're a bank and you're lending out hundreds of thousands of dollars, you can really punish people by compounding interest really frequently. So in Canada, we have protections for consumers where banks are only allowed to compound interest twice a year. That's the most they can do it. You can pay your mortgage back every week or 2 weeks or monthly, but the bank can only recalculate interest twice a year. So that's a nice thing. Let's calculate what my semi-monthly payment here is. So initially, I was going to pay my mortgage off over 25 years, and we're doing semi-monthly. We haven't used semi-monthly in a while. Semi-monthly, HL, not LH, but semi-monthly is 24 times per year. But here's where you guys have to kind of get out of that reflex. Our payments per year then is going to be 24. It's going to automatically update your CPY to 24. You got to change that back to 2. Okay? It makes a bit of a difference. It doesn't make a whopping difference, but it saves consumers a few $100s. And I'm going to be consistent with that through our mortgage problems. All right. How many payments is that? 25 years of making semi-monthly payments. 25 times 24. I think that's 600. 600 mortgage payments. So my interest rate that I got 15 years ago was 3.19%. Those went down a lot over the course of a decade. They're now back up a little bit more since COVID and whatnot. I think right now a comparable would be 4 or 4.5%, but not too much different. I guess it's not when your grandparents were borrowing money for homes, the interest rate was like 15 or 20%, except, their homes were a lot cheaper. I digress. Why'd you guys let me get off on a tangent? For our present value, you guys will note on the board here, it's not just how much we're borrowing, it's how much we're borrowing less the down payment. So we just got to do a quick calculation here. I might just tuck this in up above, but I don't have to borrow the 301,000. I made a down payment of 11,000. So that means I borrowed initially $290,000 from Scotiabank. We're solving for what my semi-monthly payment is. And of course, after these 25 years, the money's all gone. So again, nothing really new here tech-wise. The TVM solver works the same way. But make sure that you take down payment into account. Make sure if it's a mortgage question, your CPY is set to 2. But otherwise, yeah, let's find what my semi-monthly payment was initially. And then, just for fun, let's find out how much interest that would be over the course of those 25 years. Not really for fun, but it's worth doing. Okay, 600. 3.19. 290,000. Pay till it's all gone. So, yeah, my TVM solver changes C/Y to 24. We want to make sure it's 2. So pretty close to 700. Did you guys get that as well? 699.96. If you guys, we'll come back to that in a second. But note if you change it to 24. Can you guys just humor me? Change it to 24 for a sec and resolve for PMT. Note it's 701.72. You might not think not such a big difference, but it's a $2 or $3 over the course of 600 payments. So it works out to about $1,800 you save by compounding semi-annually instead, which is, it's not nothing, it's something. But anyway, $699.96. Let's wrap this one up. Minus $699. So that was my initial, I paid that twice a month. Okay. Now, yeah, let's look at the total interest. Yay. All right. So how much is 600 payments? You guys will be doing similar calculations in the final task of the year for the term anyway, your mortgage task. But yeah, how much is that? 600 payments of $699.96. So $419,976. That is ultimately, if for 25 years, I didn't change anything, I paid the same amount at the same interest rate, almost $420,000. How much of that is interest? Do a quick subtraction. Subtract how much we borrowed, that $290,000. So just from my family alone, just that one house being borrowed, Scotiabank in 25 years would make almost $130,000 in interest. So if you guys can, start a bank for sure, because they just make money like hand over feet. It's crazy. All of our big 5 banks make billions of dollars of profit every year. And this is kind of why, because they really get us with mortgages. And most of us are in situations where we just have to own a home or a condo or something. Most of us will have to do this. It just kind of is what it is. All right, let's just make some tweaks and then wrap up the lesson, okay, guys? So let's say, just changing the problem up, let's say I could afford a bit more every half month. Let's see how long it would take to pay off the mortgage. Let's find out if we bumped our payment up to $1,000. So we're still keeping that as $290,000. We're just going to change this to PMT to minus $1,000. FV0. 24, and again, with our mortgage questions, keep making sure that your CPY is 2. It makes a small difference. So that's an extra $600 a month, roughly. Let's see how much sooner I could pay things off. So we're just making a couple of tweaks. We're changing PMT to 1000. This is the beauty of the TVM solvers. Somebody at Scotiabank right now is doing this exact same thing and getting paid for it with a client. Solve for N. 300, can we just maybe call that 366? Let's call it 366. How about 366? Now, keep in mind, that's semi-monthly payments. If you want to tell somebody how many years that would be, we just have to take that 366 and divide it by 24. Why 24? Because this problem is a semi-monthly problem, right? So we just got to be mindful of that, not 12. Look at that. That's like 15.2 years. So that's almost 10 years sooner if you can afford it. Now, it doesn't take, I'm not going to write this down, but we can do it by hand. How much am I actually paying back? About 366 payments of $1,000 is $366,000. And if you subtract how much was borrowed, in this scenario, the interest is $76,000. So you save about $50,000. So it might be worth, budgeting more than, if the bank says you can do this much per month, if you can afford more, pay it off sooner and save a lot of interest. The tasks coming up, you guys are doing this. You guys are making small changes and then comparing how much more or less interest you pay for a mortgage. You guys are doing great. We got one last one to do. Dry those tears. I'm not much of a crier myself, but this is our last question. We're doing it together as part of our term. So let's savor it, everybody. Let's take it all in. All right. So the Smiths are taking in a mortgage of $210,000. That's not a lot because they're buying a tiny home, and their interest rate is 5% per year, compounded semi-annually. Can you guys, independent of me, calculate this their monthly payments? And then I'll just have a quick talk about what we call an amortization table, and then we'll wrap up the lesson. Oh, wait a second. You guys do this one. While you guys do it, actually, I'll pass around the final term task of the year before we get into the final 30. It is. It's cool. All right, let me play some catch up here. $210,000, interest rate of 5. So they are making monthly payments for 25 years. So you guys have 300 payments there, 300 payments. We're finding out what that monthly payment is. FB0, all gone. It's a monthly payment problem, but interest calculated semi-annually, so 12 and 2. Makes a small difference. Not a massive difference, but it does make a difference. All right. Now I believe our payment amount should match up what's in the table. Let's verify that. So clear things out. 300, 5%. Yeah, what'd I do? Yeah. A monthly payment. That's what happens with mortgages. You make a monthly payment, but the bank can only compound interest twice a year. Yeah. It's to protect you. Yeah, mentioned that earlier. But yes, our CPYs are 2 for our mortgage problems, okay? They don't match. The only time those won't match is when we're doing these mortgage problems. All right. P/Y is 12. Make sure you change C/Y back to 2. This should be 0. Solve for PMT. 12, 21, 37. Which matches with our table. Perfect. 12, 21, 37 per month. Okay. So tech-wise, like hopefully you guys are convinced it's the same process as before. You got to keep in mind with mortgages, your CPY should be 2. You got to keep an eye out if any problem involves a down payment to subtract it off. Now, in the grade 12 college course, if you guys take that, we actually make amortization tables like this in a spreadsheet. Not exactly part of this course, but this is an amortization table. You can get one for when you have a mortgage and just kind of see how everything pays out. Just some things to notice. If you guys look at that first monthly payment, look how much of that initial monthly payment is interest. Of that, about $1,200, about $900 of that payment is interest. You're only reducing how much you owe by like $300. Initially, when you guys get a mortgage, for the first, if it's a 25-year mortgage, about 10 years or so, over half of your payment is just free money for the bank. It's just interest. Once you pass that 10-year mark or so in a 25-year mortgage, it gets about 50-50. And you guys can see by the end of this mortgage, most of the payment is going towards paying down the principal. The interest is just a teeny tiny little bit amount. But yeah, just fun facts about mortgages. All right, I got nothing else to teach you. We are done. Let's hit pause. I promised myself I would